Section 2.4 looks at graphical misrepresentations of data. Have you ever looked in a newspaper or some kind of article and you notice that the graph is really misleading the way that they have designed it? And so we want to make sure that when we are graphing data using whatever kind of graph, that we are presenting the data accurately. And so we're going to take a look at some misleading graphs and look at why they are misleading. So the first way that you can misrepresent data is by manipulating the vertical scale. Take a look at these two graphs. Okay, they both represent the days of freezing temperatures in 2007 and 2008. They're showing the exact same data. However, the graph on the left makes it look like the number of days of freezing temps is a lot more in 2008 than there were in 2007. And then if you look at the graph on the right, it really just, it makes it look, it's a lot smaller of a difference. Okay, and so let's take a look at what is the difference. Okay, if you look at the graph on the left, you can clearly see that the difference is only 2 days. Okay, and so the graph on the left is really misleading because it makes it look like a lot more days of freezing temperatures in 2008, but the difference was only 2. Notice that on the left graph, the y-axis doesn't start at 0, and that's causing that misrepresentation. The graph on the right, the y-axis does start at 0, and so the comparison is much more accurate because it shows the total number. Each bar of the graph shows the total number of days of freezing temperatures all the way from 0 up to a possible 100, whereas the left side, the scale is not accurately showing the data. All right, we can also mislead through the size of the graphics. And so let's take a look at this picture. Okay, we have candy corn, and they're trying to use the candy corn to show how much candy was collected between these two people, Shayna and Michael. Okay, and so if you just look at the height, then you can see, okay, Shayna collected about, looks like 18 pieces of candy, and Michael collected about 36. So Michael collected twice as much candy, but if you look at the pictures, it looks like it's 3 times as much candy for Michael than it was for Shayna, because not only are they growing the height, but they're growing the width as well. And so it makes it look like Michael collected a lot more candy than just twice as much as Shayna. So the size of the graphs the size of the pictures can be misleading for the graphs. And that's one of the reasons that with the bar graphs, we've got to make sure that they all have the same width, so that way it's not misleading. So you have to be careful with pictures because in these pictures, they extended not just the height, but the width, which changes the area of the whole picture. So be careful with using pictures in your graphs. One of the things that they could have done to make this a little bit better was maybe take the same size candy corn and just stack them on top of each other. And so you're not changing the width, you're just making it grow taller. And that would have been helpful to see the difference without making it appear even bigger. All right, another thing that can be misleading is through the size of the sectors. Okay, you can divide up a pie graph, but if you don't divide it up correctly, then you're going to be misleading with your data. So if you look at this pie chart, you can see that it is totally incorrect, because if you look at the gray area, it's 265 million. And if you look at the other side, the green, the purple, and the blue, when you add that together, you get 145 million. 145 million. and yet it makes it look like the city is half. But the other side is only 145, which is not half. So these sectors are not the right size. The slices of the pie, the wedges, the sectors, those all mean the same thing. They're not the same. They're not proportional to the total. And so that's misleading. The city is actually more than half. The funding comes from more than half. Or more than half of the funding comes from the city. So this pie chart is misleading because the sectors are not the correct size. So some guidelines for good graphics. First, you want to make sure that you title and label your graphic axes. Make sure you include units, data sources, and explanations. Try to avoid any distortion. Try not to have too much white space in the graph. If you truncate scales, like if you don't start at 0, you have to indicate that to the reader so that they know that. Try not to have too much clutter in your graphic. Don't use 3D graphics because that can be very misleading. Use only one design. Don't try to use more than one design at a time. And then avoid relative graphics, or graphs, avoid relative graphs that don't have data or scales. And these are just some guidelines. You're not going to be creating graphs that would be misleading probably, but you will need to identify maybe the problem with the graph. All right, so if we take a look at this problem, we want to look at, okay, so we've got the cost of raising kids, and so housing is 33%, food is 18%, transportation is 15%, and 11% is in the other category. So how is this graphic misleading, and what could be done to improve the graphic? So let's take a look at this. All right, so we've got a sideways bar graph, a horizontal bar graph, which is totally fine. Now, what do we notice about the percentages, first of all? They don't even add up to 100%. The total percentage is only 77%. So what happened to that other 23%? Who knows? Because they've got an other category. So where did that, what's in other and what's missing? Okay, and so that part of the graph is misleading. Another part of the graph that's misleading is, okay, well, you would expect the 33% to be a lot longer than the 15%. Housing should be more than double transportation, and yet in the bars, it's not more than double. And so the lengths of the bars don't really correspond to the percentages. And there are no axes, really. So it's hard to tell what they're trying to do with those percentages. I'm guessing it doesn't start at 0, but there's no axis, so you can't tell. So those are some of the things that you could do to change it. You can make sure you have that axis that's showing you the units that you're using for the percentage. So maybe start it at 0. That way it's clear. So the lengths of the bars would be proportional. You would also want to make sure that you're including that other 23% wherever it is. There's also no information about where they got their numbers. How did they collect their data? There's no explanation of it. So there are a lot of things that could be improved on this particular graph. All right, let's take a look at the next one. And this one shows the rising cost of college. Okay, and so we look at this graph and we see, okay, well, Cornell's tuition has gone up from 1965 to 1999, and their ranking has gone down from 1989 to 1999. Okay, well, first of all, you're looking at two different sizes for the period of time. Okay, from 1965 to 1999 is 34 years. But from 89 to 99 is only 10 years, and yet the graphs are the same length. So that first is misleading. Second of all, it makes it look like, okay, so their tuition has gone up, but their ranking's going down. So it makes it seem like they're not as good of a school anymore, but they're charging more. But if you think about ranking, because this graphic doesn't tell you what ranking means, if you're looking at university rankings, you want to go to the number 1 or number 2. I mean, you want a low number for your ranking. So that's actually a good thing. Okay? But this graph makes it look like a bad thing because it's going down. But you want the number to go down because you want a higher ranking, which the higher ranking is the lower number. So that part of the graph is very misleading because it looks like they're not as good of a school when they're getting better in their ranking. Their ranking is actually getting higher, but that means that the number is getting lower, so the graph shows the number. And so those are just a couple of examples of misleading graphs, and we kind of talked about why they're misleading. So again, you're not going to have to create misleading graphs. You're just going to have to recognize, okay, what makes this graph misleading?